The velocity time graph of an ascending passenger lift is given. What is the acceleration of the lift in the first 2 seconds? Let's mark the region of acceleration. So it is here. This is the acceleration in the first 2 seconds. So this is our initial point and this is the final point. So the initial point we will write as O, which is already given. The final point we will write as A. So let's look for OA. What is the acceleration? And to know the acceleration, we need to know initial velocity, final velocity, and the time taken for this change in velocity. If you look up at the graph, you see the initial velocity is 0 meter per second. The final velocity is at A, V, which is V, and that is 4.6 meter per second. The time taken for this change is, the time at A is here, which is 2, and the time at B is here. So the time here is 4 minus, the time here is 2 minus 0 and 2 seconds. As we have seen, the initial velocity was 0 meter per second and the final is 4.6 meter per second. So the acceleration for OA is V minus U over T. Our V is 4.6, this is the V, this is the final point, minus the initial point is this, 0, over the time, this is the time, this time 2 seconds is the time taken for this change. So that is 4.6 over 2 and 2.3 meter per second square is the acceleration along the first 2 seconds. Now next we have to find the acceleration between the second and the 10th second. So to find the second, this is the second and this is the 10th one. So we need to find the acceleration between these points. So what happened between the second and the 10th second? Let's see here. The body from here moved up to this point. So this is what happened in between the second and the 10th second. The body moved with a constant velocity. Have you seen? Which was 4.6 meters. So we'll mark this point as we mark this as A and this will mark as B. So let us see along AB. We'll find what is the initial velocity, what is the final velocity, and the time for AB. If you look up here, you will see that the initial velocity is 4.6 meter per second. So we will write that 4.6 meter per second. The final velocity is also V, final, 4.6 meter per second. The velocity hasn't changed, 4.6. The time is, if you see here, the time for B was this and the time for A was 2. So the time will be 10 minus 2 and that is 8 seconds. So acceleration V minus U over T, which is 4.6 minus 4.6. Velocity did not change, over 8 seconds, and that is 0 meter per second. So between the second and the 10th second, here the acceleration was 0. Here the acceleration was 2.3 meter per second square. Now they said for during the last 2 seconds, which are the last 2 seconds? This 12 is the last second, and before that would be 10. So we must know what is happening between 10 and 12 seconds. At the 10th second, the object was at this point, and at the 12th second now, the object is at this point. So here we'll call these points as, this was B, and we call this as C. So we'll see what is happening along BC. Like earlier, we'll find the initial velocity, final velocity, and then we will find the time. So the initial velocity here at B, if you see, is, this is the starting point for this motion, for the last, this is the motion for the last 2 seconds taking place here along the blue line. So the initial velocity is 4.6 meter per second, and here the final velocity is 0 meter per second. Have you seen the object has stopped? See the 0 meter per second. So u is 4.6 meter per second, and finally the object stops, so it is 0 meter per second. And the time taken for this is this portion here, 12 minus 10, and that is 2. So the acceleration in this case, v minus u over t. So acceleration, the v is 0, your u is minus 4.6, and the time is 2. So minus 4.6 over 2, and that would be minus 2.3 meter per second square. So we got the acceleration, this retardation is minus. Why did we get minus? Because it is retardation. So for this last one, the acceleration is the acceleration for this is the a equal to minus 2.3 meter per second square.